Hi, welcome back with the second part of the lesson gas law. We have studied Boyles Law. Now we will study Sharples Law and chaotic or combined law of gases. What happens to the volume of a gas when you increase the pressure, press string that is tapered? Like this, we have string and we push. What happens? The amount of a gas is constant, or number of molecules doesn't change, but what changes? The volume and pressure. Volume and pressure. Why? Let's investigate the relationship between pressure and volume if the quantity of a gas and temperature are held constant. In this investigation, we use the piston, cylinder, and piston. This is piston movable, and we change the pressure and measure the volume and record in this table like this. With increasing pressure, the volume decreased. What is the mathematical relationship between P and V? P multiply V equal constant, because if we multiply P and V, I will have the same result is 5,000. So this is the Boyles Law. In the 17th century, Robert Pipe described this property as the spring of air. Boyles showed that when temperature and amount of a gas were constant, then P proportional with 1 over V, or V equal constant equal K. Now consider we have two balloons. The two balloons filled with equal volume of air. What happens to the volume of each if one is heated and the other is frozen? It means I will increase the temperatures for this one and decrease the temperature for this one. Heated balloon start with 50 Celsius, volume was equal 1.18 liter, and the frozen start with 40 and 30 decrease the temperature and the volume also decrease, but the other one increase the temperature and the volume is increased also. So to study the relationship, let's look at this data in table like this. Temperature and volume. With increasing temperatures, the volume is increased, and graph this data using temperatures as the independent variable. It means the temperature will take horizontal axis, but volume will be represent in vertical axis. This is temperature and this is volume. This point to which we take it or record it in the experiment. If we extend this straight line, it will cut at 0 volume. I will have 273.15 Celsius. This is called absolute zero. Minus 273.5 Celsius is known as absolute zero. When using gas laws, temperature must be expressed using a temperature scale where 0 is 273.15 Celsius. This is called the Kelvin Scale of absolute temperature. And we know that we in gas law or any problem for gas law, we must express by Kelvin temperatures. So we need to change Celsius scale to Kelvin scale by adding 273 to the Celsius scale to have Kelvin scale. When changing Celsius to Kelvin, simply add 273.15 or 273 only negligible for 0.15. What is 12.3 Celsius in Kelvin? It will be equal 285.48 by adding 273 degree. Now let's look at this table with temperature in Kelvin. This is a change between temperature in Kelvin and volume by adding to the Celsius or the previous table 273. Can you spot mathematical relationship between T and V? Yes. T over V in Kelvin is a constant. If we divide volume over temperature, I will have a constant value is 0.0037. This is a constant, and we will see the relationship, this relationship or this law called Sharples Law. In the 17th century, Sharples examined the relationship between temperature and volume. Sharples showed that when pressure increased and amount of a gas were constant, then V proportional with T, or V over T equal K. And we can combine gas law, it means Sharples law and Boyles law, like if V1 P1, this is the first state, equal V2 P2, this is the second state, and this is Boyles law, and start with Sharples law, V1 over T1 equal V2 over T2. We can combine them in one law like this. V1 P1 over T1, this is the first state, equal V2 P2 over T2, this is the second state, and this is called combined law, or we can write it as a simple form, equal V1 P1 T2 equal V2 P2 T1. What does P2 equal? If we want to calculate P2 in this law, what we will do? We will divide two sides by V2 T1 to have P2 as a subject in one side, like this, and cancel V2 V2 and T1 T1 to have P2 as a subject. Boyles law, at a constant T and N. What's the meaning of N? Means number of molecules of a gas. It means the mass of the gas is equivalent to change. T and N constant, so I will have Vp equal K. Sharples law say at a constant P and N, V over T equal K. And combined gas law for fixed quantity of a gas, Vp over T equal K. So maybe this is the first case, and second case, first case we can say V1 V1, second case V2 V2, first state and second state also V1 over T1 equal V2 over T2, and V1 P1 over T1 equal V2 P2 over T2. We will solve some problem about gas law and how we can use relation in solving this problem. If 12.5 liter of a gas at a pressure of 125 kilopascal is placed in an elastic container at 15 Celsius, what volume would it occupy if the pressure is increased to 145 kilopascal? So at first I will write the given value or a given parameter. He gave me V1, this before in change or the start case, V1 and B1 and T1. So I have all parameter, volume, pressure and temperature for the first case or at the start of the investigation. After that, I didn't know the volume, but I know pressure and temperature. Pressure 152, it changed to 145. Temperature didn't change, so I can cancel temperature from two sides of the relation like this. V1 P1 over T1 equal V2 P2 over T2, so I can cancel T1 and T2 because they are equal. So V1 P1 equal V2 B2. After that I substituting by V1 equal 12.5 liter and P2 equal 125 kilopascal, and V2 I don't know it, and V and P2 equal 145 kilopascal. By divide by 145, so I will have V2 equal 10.8 liter. Does this answer make sense? Yes. If I have outside pressures equal 165 and compress in elastic container, the volume will decrease until it's reached to 10.8 liter and stop at this point, didn't change after that. Another example, if I have 15.6 liter of a gas at a pressure of 165 kPa is placed in an elastic container at 15 Celsius, what volume would it occupy if the temperature is increased to 98 Celsius? At first we write the parameter, the given parameter V1, P1 and T1. V2 I don't know it, T2 98 Celsius, P2 T2 equal 98 Celsius, P2 equal 165 kilopascal, and write the relation and see which parameters are equal in two cases. Yes, P1 equal P2 equal 165 kilopascal, so I can cancel P2 with each other and have a simple relation V1 over T1 equal V2 over T2, and I need to calculate V, so I will multiply each side by T2, so I will have, and don't forget, change Celsius to Kelvin by adding 273 degree and substituting about V1 and T1 and T2 and calculate V2 as 20.1 liter. Another example, if 5.3 liter of a gas at a temperature of 75 kilopascal is placed in an elastic container at 24 Celsius, what volume would it occupy if the temperature is increased to 62 Celsius and the pressure to 155 kilopascal? Given parameter V1 and B1, T1, V2 and T2 and B2, we see that T1 equal 24 Celsius and T2 equal 62 Celsius, so I can't cancel each other. 21 didn't equal T2, and also the pressure P1 didn't equal the pressure P2, so I wouldn't cancel any parameter of the relation. V1 P1 over T2 equal V2 P2 over T2, and yes, I will change the temperature from Celsius to Kelvin by adding 273 to the Celsius and make V2 as the subject of the relation and substituting by other parameter to calculate V2 equal 2.9 liter. Thank you. I hope so you fully understand Boyles Law and the application about it. Thank you. Goodbye with the next lesson in physics.